So still in Chapter 1, Lesson 1.2, the basics of functions and their graphs. Now, these are the objectives. Again, you can pause, look them over, and we, of course, will do them as we do our lessons. We want to give you now some general background on a number of key words that are important in our lessons. So this will be background, and here's what I'd like you to include in your notes. Now, in math, certain words have specific meanings, and we want to look at the relation, the term relation. What is a relation? Well, in our English language, it's somehow things are connected. And one of the best examples of a relation is the ordered pair that we mentioned in the previous lesson. So an ordered pair is an example of a relation. They are connected together. Now, within the ordered pair, we have the X element. That is what the domain is. So the X elements of ordered pairs or anything related to this refer to the domain. And the range is the Y elements. And you might say, how would I remember that? Well, if you have domain in range alphabetically, then X, Y alphabetically pair with them. Now, in this section that we're dealing with, which relates to function, again, this is a mathematical concept and an important idea that we'll be dealing with throughout. What is a function? Well, something is a function if the X element in that series of relations is only used once. Now, we'll see some examples of all of these, but this is some good notes to take down at this stage. So, example 1. Remember we said we're putting boxes around, help us to identify. Finding the domain and range of a relation. So here are a set of ordered pairs, and we want to find the domain. So they have it listed here, and the domain again would be the first element, the X element. And that's what they've listed here. Now another word I'd like you to write down for background is what we call roster notation. Now, roster notation is a way of writing sets of things where we use a brace and then list the elements individually. So this is roster notation of our domain of these relations. Now the range, and I'll change color here, would be the Y values that they're just listing. Now notice that here none of our X values are repeated. So this would also be a function. And we'll see more examples of this as we go on. Now we covered this in an earlier slide. The function is where the X value in a series of relations is only used once, exactly once, as related to a range item. All right, let's go on and determine. This is example number 2. and I'll go back to red, whether this series of relations is a function. Now, just looking at this, remember this is in roster notation, and these are ordered pairs. So we look, 1, 3, 6, 8. The X element's only used once, so this series of relations is a function. Now, for this slide, as we look at it, this would be a good statement to write in your notes. Functions as equations. I'll read it slowly. If an equation is solved for y, and more than one value of y can be obtained for a given x, so in a sense indicating the x is used more than once, then the equation does not define y as a function of x. Now, for example 3, and we're looking at this slide here, it's determined whether y defines a function of x, and this is the initial equation. Well, the first thing we have to do is solve for y. So we're going to take this term, move it over to the other side. That's what we have here. Now we take the square root of both sides. This side just becomes a y, and this will become a plus or minus what we have here. Write that down. Now when we graph this, it ends up looking like a circle right around the origin. Now notice that there's an x value there and there's an x value there. So the x values throughout this area enclosed by the circle are used more than once. So this does not define this y in this equation as a function. Now we have another thing we'll show you later that relates to this. Now throughout math we have a number of notations. We did roster notation. Now we're doing function notation. We use the symbol f of x to be read as f of x or f at x. That represents the function notation of something, which is what the value of that x would be generally in this rule that they will give us. We've seen a couple of examples of this already. Now, for example 4, they're asking us to evaluate a function. So, if we have this, and this is f of x equals x squared plus 2x plus 7, where x now will be a negative 5, what would be the protocol for that? And they've written it out so we can follow it. You had to write it in your notes. So there is your basic statement. Now, something is we are going to input, and sketch this out too, something into a rule, and then we get an output. So the input value is our x value, and our output is the y value. So this is sort of what's going on, but you need a protocol to do this. So our x value is a negative 5. So within a parenthesis, I'm going to put a negative 5. That's squared. Then minus 2 times negative 5 plus 7. Now if we square a negative 5, we get 25. Now a negative 2 times a negative 5 gives us a positive 10. And we get 35 plus 7 is 42. Thus, this function in this rule gives us this value. Input into a rule gives us an output. Now, the graph of a function is the graph of its ordered pairs. And normally you would set up a t-chart, as we did in a previous lesson, get various values and then plot them, and then carefully connect the points to develop the graph. So here, for example 5, we're asked to graph this function f and this function g on the same rectangular coordinate system. Select integers of x starting with a -2 and ending with a 2. So again, this is example 5, and then this is what we're looking for. So there's our function, and there's our t-chart that I want you to sketch. There's your t-chart, and there's the function I want you to sketch. Hopefully you make straighter lines than I'm doing with my little tablet here. So if x then is a -2, your y value here will be a -4. If it's a -1, -2. If it's 0, 0, 1, 2, 2, 4. Now notice you're getting the start of it, but then you have to subtract 3 from this result. So again, pause, sketch it. And then what do you notice? Well, keeping in mind that this function notation is actually in slope-intercept form, where we have y equals mx plus b, relating it to a previous lesson. Now here, there is no b value, so our b value is actually 0, while here our b value is a -3. And we said our b value was the y-intercept. So notice there is 1, 2, 3. There's our y-intercept. Here where it's 0, our y-intercept is 0. Oh, works out very well. Now this is actually the slope, and we'll be dealing with slope a little more in our lessons here later, and showing you that these lines are actually parallel. They have the same slopes, but different y-intercepts, and this is our little proof of it. Now, here is another item for background and a tool for our mathematical tool chest. Now, we speak of what is called the vertical line test. What is that? Well, we have a vertical line, and then we're going to take this vertical line and pass it over the graph. And as this line goes over the graph, does it intersect the graph that would be here in more than one place? And if it does more than one place, it's not a function. But if it only intersects in one place at a time as you move it over the face of the graph, then that is a function. So let's take a look at this and see if these various shapes pass the vertical line test and therefore would be a function. So for this, it's example 7. And you're just going to quickly sketch these. It shouldn't take too long. It doesn't have to be exact. And if you could use a different color for the graph. Now, this little line here that they're calling the red line, which is our vertical line that we're moving over the face of the graph, is this line intersecting that blue line in more than one place at a time? No, only one place. So it's a function. But how about this squiggly blue line? No, it intersects it there and there and there. So this is not a function. And how about this one? Again, the red line is moving across this graph. It's only intersecting in one place. This is a function. And here, something similar to one we did a little earlier. This intersects in more than one place, so it is not a function. So which mathematical tool are we using to determine whether something's a function or not? The vertical line test. Now later we're going to have the horizontal line test, but right now we'll start off easy. Now they have some extremely useful graphic displays of things. So for example 8, it says analyzing the graph of a function. Here they're saying that our x value is 5 and our y value is 400. Now let's find that on the graph. So our x value is 5, would be right there. And our y value of 400, there it is right there. We bring it over, and there is our 400. Very good. For what value of x is our y value now of 100? Let's look at that. Now 100 is right about there. Bringing that over, and it's right about there. And that x value then is 9. So a nice visual of how to do items like this as you do your homework. But this, again, a light sketch of this in, for example, 8. Okay, now what we're going to do is take a look at a graph and then determine the domain and the range from a function's graph. And we'll go over that protocol in our next slide here. Okay. So, again, make a little sketch of this. This is example 9. Let me highlight that for you. And the graph would be just something like this. And then you want this point and this point. And in a sense, you could do that point too if you like. It looks like so. So, we're looking for x values. What we do is we project the blue line down onto the x-axis. And I went a little too far on that. Let me go back here. So it would be here and then to there. Now, how would I write that in interval notation, which is another notation you may or may not be familiar with? Well, because -2 is included in the system, we use a bracket. So this would be -2. And then projecting this down to this point, this is a +1, and 1 is included. Okay. Now, they're showing us in another method here of showing notation, and I perhaps should tell you that. Let me write some things out, and then we can copy it into your notes. So we're seeing the domain here listed in 2 notations. This top one is when you have a brace and you have an X. This is red. X is such. And then they sort of define it with algebraic symbolism, notation, close it. So this would be, again, brace, X is such that, and then they give you a definition. Close it with a brace. This is called set builder notation. Now, this one here, where we define the elements illustrated by this is, and let's write that down again, interval notation. So you can be doing it as I do it. Now, again, domain are the X values. Range are the Y values. Now here it is in set builder notation. And I'm going to clear this up here a little bit because now what we want to feature is the blue line reflected, and I'll change to blue here, onto the y-axis right down there. So it's starting here at 0 and it's going up to a positive 3. So in interval notation, that would start at 0. Again, we're reflecting this blue line to the y-axis, so that would be 0, 3. And that's what they're showing here. So again, useful information as you do your homework and build your vocabulary for functions notation. Continuing defining in example 10 here, the domain and the range. Well, since I have blue, I'm going to do the range first. Now again, we're projecting this blue line to the y-axis, and it looks like a hollow at 2 and a solid dot here at 1. So in interval notation, we start from the bottom here. This would be a -1, and because of that solid dot on -1, as we project it to the y-axis, and then going up to the hollow where it indicates it's not included in the set, we get a 2. And since it's not included, we're going to use a parenthesis. And that's what they're showing here. I didn't make a very good 2 there, but this is a better one. All right, clearing that up now. I'll go back to red. We want to project this blue line to the domain, which are our X values, which would be a hollow here also, and going to a solid dot there. And in interval notation, it would be a parenthesis for 2, and then a solid dot for 1. We'd use a bracket, and that's -2, yes. Don't want to forget that. Okay, so once again, in review, we have a little time. When we are determining domain and range, we project the graph to, for the domain, the x-axis, for the range, the y-axis, and then write it in interval notation. And above here is set builder notation. And, include these in your notes. As we wind this up, something else they'll be asking about graphs is to find the x-intercept. Remember, that's when you have an x value and y is 0, and the y-intercepts, where the x value is 0 and you have some y value. So in some cases, you may have more than 1 or 2 of these, and you list them, but the x-intercepts will always be listed in this fashion, the y-intercepts in this fashion. Let's go on now to our last slide. And check out the intercepts. Again, this is laid out. This will be example 11. And make a brief sketch, and you can just pop some lines here. Now notice you have 3 X-intercepts and 1 Y-intercept. And there they are listed here. Okay, again, these will be open notes quiz items. You want to have good notes.